Hello and welcome to Web Math Academy. Today we're going to go further into our discussion of derivatives and provide some real-life examples of how you can apply them. Let's use two motion type problems and we will discuss what we call a rate of change problem. First, let's try this at top here. A football is tossed straight up into the air with a velocity of 48 feet per second, which is roughly 32.7 miles per hour. Its position above the ground at time t seconds is given by the function s of t equals negative 16t squared plus 48t. We want to know what is the football's greatest height and at what time does it reach that greatest height. Okay, in motion problems, the velocity happens to be the derivative of the position, and the acceleration is the derivative of the velocity, or to put it differently, the double derivative of the position. Let's calculate these either by hand or by using our TI-Nspire CX2 CAS calculator. First, we once again give our position function as s of t equals negative 16t squared plus 48t. If we take the derivative of that, we come up with the velocity, v of t, and that equals negative 32t plus 48. And if we take the derivative of the velocity, then we get the acceleration, which is the constant negative 32. You can also get these using our calculator. You can see I have them listed right here. The derivative with respect to t of the function is 48 minus 32t, and the derivative of that, or the double derivative of the initial function, is just simply the constant minus 32. If you don't remember how to get these values, there's two ways to do it. One is to hit this button right here, and then click on the derivative. Or you can also go to Menu, Calculus, Derivative, and here's where we have it. We want it with respect to t, and then we just put in our function here, and it'll give us the values that we have up here. Okay, moving back to our problem. To find the football's greatest height, what we need to do is determine where the velocity equals 0. In other words, at the very highest point of the football is when it stops motionless for a second and then begins its trajectory downward. So we simply set our velocity, negative 32t plus 48 equals 0, and solving for t, we see that t equals 1.5 seconds. So at 1.5 seconds, the football will have reached its greatest height and then it'll begin falling downward. Now if we wanted to know the height at this time, we just plug it right into our position equation. Negative 16 times 1.5 squared plus 48 times 1.5, and it equals 36 feet. So that's the highest point that the football will reach in its trajectory. Interestingly, that constant, the minus 32 for the acceleration, that happens to be the downward acceleration of gravity, which is 32 feet per second squared. Now on to our second problem. Uh-oh, an airplane is leaking jet fuel out of its main 1,000-gallon tank. If the amount of fuel remaining in the tank is given by the function a of t equals 0.4t squared minus 50t plus 1,000, how much fuel is leaking at t equals 5 minutes? And is the rate of leaking increasing or decreasing at this time? And finally, most important, how long until the tank runs dry? Well, first we want to find the rate of change by taking the derivative of a of t. And the derivative of a of t equals a prime of t equals 0.8t minus 50. So if we take this derivative and set t equal to 5 minutes, then the rate of change is 46 pounds per minute. And you can also find this out through your CAS calculator by taking the function 0.4t squared minus 50t plus 1,000 and simply take the derivative of it. Now if we take the derivative again, the second derivative of a of t, we get equals 0.8, which is a positive number indicating that the leaking is slowing down with time. So this means that the tank is losing more fuel to begin with than as it goes on. And finally, to find out when the tank will run dry, we just set the function 0.4t squared minus 50t plus 1,000 equal to 0. And we can use our CAS calculator to solve this equation. I have it situated right over here that you can see, and let me just show you how to do that. You just go to Menu, Algebra, Solve, and then you put your function 0.4t squared minus 50t plus 1,000 equal to 0. then a comma, and put down what variable you want to find. And in this case, it's t. It could be x or b or whatever else you've chosen, but you have to put that in there, otherwise it won't work. And you can see that comes out with two values, t equals 25 or t equals 100. Well, in a physical sense, the tank can't run out of fuel twice, so we really want the first answer as to when it will run out, and that is 25 minutes. So these are just two interesting problems that you can use to see exactly how you can use your TI-Nspire calculator to come up with derivative and algebraic functions.